wonderful Tuesday. As usual, we start here with the title of our lesson, What Happens When Environments Change? All right, your homework, fast and slow changes. All right, here is Bo's fast change, tsunami, slow change, landslide. Bo, can you tell me, name 2 organisms and tell me what would happen to them?
The people and plants will be washed into the sea.
Okay, excellent. Some people and plants will be washed out into the sea. Very good. All right, here's Dammy's. Very nice, Dammy. Also has a tsunami. And, oh, you did climate change as your slow change with your greenhouse gases. Very nice. Dammy, can you tell me 2 organisms that will be affected by this and how? It could be a good thing, it could be a bad thing.
The Arctic is melting.
So what are 2 organisms that would be affected by that?
Polar bears.
Mm-hmm.
I can't think of another.
There's the Arctic fox. The Arctic fox that follows the polar bear around to get its food. Maybe even some animals would like that. Maybe now some animals can move further north, like the buffalo likes kind of cold weather, right? They're mostly in North America, but when it gets warmer, maybe they can move up into Canada. They have a bigger habitat. It could be good for some animals, but it's mostly bad. Zoiming, with very little effort. Zoiming, this is not what your homework is supposed to look like. I don't even think we can count this as homework. Where is your drawing? All right, our artist Fred. Wonderful job, Fred. Oh, fast change, you did a hurricane. Slow change, land formation. Very nice. Fred, how does a hurricane change the land? How does it change Earth's surface?
It takes everything.
It takes everything, it picks it up and moves it somewhere else. Okay, very good. It could do that to sand, rocks, animals, plants. All right, this one is, I believe, Hanling. Oh, a very special slow change and a different fast change. Very good, Hanling. This one, I'm actually not sure whose this one is.
Me.
Okay. Sup, very nice. I should have known from the faces on your animals and your son that this one was you. What is your fast change, Sup?
Hurricane.
And what slow change did you draw?
Get the temperature is getting warmer and the ice is like turning to a water.
Very good. It's melting, turning to water. Nice job, Suck. All right, khaki. Let's take a look at khakis. Oh, nice. Okay, so just a quick spelling. This is formation of soil or the breaking down of rocks. All right. And drought. Okay, nice. So khaki, can you explain why is breaking down formation of soil a slow change? Why is that a slow change? How long do you think it takes? 1 year. Well, we know that rocks can be broken down by different things. What's one thing that can break rocks down?
Wind.
Wind. Remember, wind can weather the top of a mountain. Do you remember how long that can take? Everyone unmute. Tell me, how long do you think it takes to weather a mountain? So it goes from this to this.
1,000 years. 1,000 years. 1,000 years.
Actually, 1,000 years is not even that long. It could take 1 million years. Weathering by wind is very slow. Remember, we also have ice. The ice can break rocks because ice takes up more space than water. So when the water in the rock freezes, it pushes it apart and makes the cracks bigger and bigger. Weathering by ice could take, who knows, 100 years, maybe more, maybe less. There's water, weathering by water, like the Grand Canyon. We can form canyons, right? Weathering by water, we can form canyons. Oh no, spelling mistake. Canyons. There we go. Very nice. And drought. Drought is special. Some people think it's a fast change. Some people think it's a slow change. Kaki, how much time do you think it takes for a healthy land to turn into a drought?
100 years.
100 years? That might be too long. Think about here in Hanoi. If it was sunny and hot every single day with no rain, how long do you think it would take to go into a drought?
1 month.
Yeah, 1 month I think that could be it. So everyone can answer these questions. Ready? Is 1 month shorter or longer than the time it takes a volcano to erupt?
Slower.
1 month. 1 month. 1
Is-
month.
Is 1 month, let's say slower or faster? Is a drought slower or faster than a volcano eruption?
Slower. Slower. Slower.
All right. Is a drought slower or faster than weathering, than breaking down rocks?
Yes! Faster. Very fast.
Good. Is it slower or faster than a hurricane?
Slow.
Slower.
Slower. So the drought kind of goes right in the middle. It's still a fast change, but it's not as fast as an earthquake, a tsunami, a hurricane. But it's definitely not as slow as this either. All right. Thanks, Kaki, for drawing about that. Katie, excellent job, Katie. Oh, forest fire and climate change. Beautiful drawings. Katie, can you tell me what happens to the plants in a forest fire? There's more than one answer because all plants are different. What do you think?
They die.
They die. Do all the plants in a forest fire die?
I think no.
No. Who remembers, is there a plant that likes forest fires?
The something cone.
Yes, conifer cones, the cones of pine trees love forest fire so that their seeds can pop out of the cones. Nice work, Katie. And good memory from last class. Kuhn, your drawings are nice, but you just wrote the word title, so I'm not sure what they are. Kuhn, can you tell me what your 2 titles should be? So this is going to be a slow environment change. People pollute the ocean. There. In fact, this is a bit long, so you could even just say people pollute the ocean. That can be your title. So what should you make the title of this other one? What is this, Kuhn?
The tsunami.
There you go. Okay, Nancy, very good job, Nancy. We have a volcano eruption and erosion. I like seeing your canyon and your river getting bigger and bigger. Nuna, very, very cute. We have another fast change that is drought, another climate change. Aw, your polar bear is very cute. Nice job, Nuna. Ruby, very good. Oh, mudslide, that's a new one. And erosion, very good. and Ryan. Earthquakes and ice melting. Nice work, everybody. You guys did a very good job on your homework. Anyone else do their homework but just not turn it in? Let's see. Spotlight video. Mooney, go ahead and tell us what your fast and slow change are.
Drought.
Drought, very good. And what's your other one?
Human cut tree.
Human cutting trees. Who remembers the new word we learned for humans cutting trees? Zoiming, what is that called when humans cut down trees?
Deforestation.
Very good, deforestation. Let's see, Jenny, do you want to quickly hold yours up in front of the camera just so we can take a look? Oh, forest fire, very good. What's your slow change? It's a little hard to see.
So ice is melting.
The ice is melting, okay. All right, go ahead, Venchi, hold yours up so we can see it. Oh, so cute, Venchi, that's amazing. Very, very good. You have a drought. Nice. Next time, send a picture of it, okay? That way everyone can see it easier.
Okay. I saw a penguin and a sea in climate change.
And how is the penguin affected by climate change? What might happen to the penguin?
The penguin live in ice. The ice melt, and the penguin don't have anywhere to live. It will be extinct.
Be extinct. It might go extinct. Very nice. Thank you, Vanchi, for sharing. All right, back here. I wanted to watch the video we watched last class one more time because there were a lot of new words. For example, deforestation, right? Just like as Zoiming told us. All right, what about overpopulation? Who remembers what overpopulation means? Ruby?
Too much people.
Yes, too many people, exactly. And that means we have too much trash, too much plastic, too much deforestation because there's too many people. What about endangered? Ryan, what's endangered?
I think endangered means they are in danger of the number of it.
Exactly, in danger of going extinct. There's only a few left, so they're endangered. They might go extinct if we're not careful. So let's quickly watch this video again.
There was a time before our ancestors smashed flint and steel together, when they felt the cold lack of fire in their lives. But anthropologists theorize that early hominids relied on lightning to cause forest fires, from which they could collect coals and burning sticks. Fire gave them the ability to cook food and clear land, and became central in many rituals and traditions. So instead of seeing forest fires as an exclusively bad thing, ancient humans may have learned to appreciate them. Yet it wasn't just humans who benefited from these natural phenomena. Even as they destroyed trees, fires also helped the forest themselves, however counterintuitive that seems. In fact, several forest species, such as select conifers, need fire to survive. But how can fire possibly create life, in addition to destroying it? The answer lies in the way that certain forests grow. In the conifer-rich forests of Western North America, lodgepole pines constantly seek the sun. Their seeds prefer to grow on open, sunny ground, which pits saplings against each other as each tries to get more light by growing.
All right, what do the long pine saplings need to grow? Simon?
They need light to grow.
Very good. They need lots of sunlight. Kitty? What happens if more and more keep growing and none of them die?
It will be bigger and it will take all the light, and then no more seeds can grow.
Exactly. Excellent job, Kitty.
Straighter and faster than its neighbors. Over time, generations of slender, lofty lodgepoles form an umbrella-like canopy that shades the forest floor below. But as the tree's pine cones mature to release their twirling seeds, this signals a problem for the lodgepole's future. Very few of these seeds will germinate in the cool, sunless shade created by their towering parents. These trees have adapted to this problem by growing two types of cones. There are the regular annual cones that release seeds spontaneously, and another type called serotinous cones, which need an environmental trigger to free their seeds.
A trigger is something that starts something. Like maybe if you get angry really easily, you could say something is your trigger, like, oh, whenever my students talk, it's my trigger. It just sets me off. I get so angry. These pine cones need a trigger, something from the environment to start them, for them to release. Everyone say trigger.
Trigger.
Excellent. Trigger to start something. Like Nancy, what can trigger a landslide?
Not growing enough trees to hold the land firm.
Excellent. Not having enough trees to hold the soil in place. A big rainstorm. What would trigger a tsunami? Boo.
Earthquake under the water.
Exactly. An earthquake out in the ocean will trigger a tsunami. Ruby, what triggers this pine cone to let its seeds go out?
The fire.
Yeah, the fire. Nice.
Serotinous cones are produced in thousands and are like waterproof time capsules sealed with resinous pitch. Many are able to stay undamaged on the tree for decades.
Kaki, how long is a decade?
I think 10 years.
There we go. Yes, it's 10 years. 10 years. So for decades, 10, 20, 30 years, it can stay on the tree like this.
On the tree for decades. Cones that fall to the ground can be viable for several years as well. But when temperatures get high enough, the cones pop open. That in action. Once it's gotten started, a coniferous forest fire typically spreads something like this. Flames ravage the thick understory provided by species like Douglas fir, a shade-tolerant tree that's able to thrive under the canopy of lodgepole pines. The fire uses these smaller trees as a stepladder to reach the higher canopy of old lodgepole pines.
All right, if we stop forest fires from happening, then we have all of these. We have so many more plants on the ground. We have bushes. We have dead leaves. Maybe we have a few smaller trees like these ones. All right, we have all this more stuff on the ground, more trees. So look at this now. What do you think might happen if there's a forest fire and you have all of these other plants and bushes and trees and dead leaves on the ground? How might the forest fire be different? Katie?
I think the forest fire will clean up the floor and everything, and the forest will form again, and it has less trees.
Very good. Okay, exactly. Very nice.
Fire uses these smaller trees as a stepladder to reach the higher canopy of old lodgepole pines. That ignites millions of seeds which are carried by the hot air to form new forests. After the fire, carbon-rich soils and an open sunlit landscape help lodgepole seeds germinate quickly and sprout in abundance. From the death of the old forest comes the birth of the new. Fires are also important for the wider ecosystem as a whole. Without wildfires to rejuvenate trees, key forest species would disappear, and so would the many creatures that depend on them. And if a fire-dependent forest goes too long without burning, that raises the risk of a catastrophic blaze.
So if there's even more leaves and bushes and trees all over the ground, the fire gets too big. Catastrophic means just a really, really, really bad disaster, a lot of damage. If it goes too long without a forest fire, that's when the forest fire gets really, really dangerous.
Which could destroy a forest completely, not to mention people's homes and lives. That's why forest rangers sometimes intentionally start controlled burns to reduce fuels in order to keep the more dangerous
So now that we've seen how environments change, we want to see how plants and animals survive these changes. Exploration 2, staying alive. Benji, what does alive mean?
To not die.
To not die, exactly. To survive, to be living. All right, everyone, please turn to page 325. Fire, this is what we're reading about. Wildfires start with for many reasons. It could be the forest is dry and there's a lightning strike without any rain. Maybe it's from heat lightning. All right, the lightning creates a spark that can set dry bushes, grasses, and trees on fire. All right, and this can wipe out much of a forest environment. Ryan, what is wipe out?
It means to erase.
Exactly, to erase, to go away, wipe out. See, we have not heard from Jenny in a while. Jenny, can you read about a population?
Population is made up of all the members of a certain kind of plant or animal in a specific area in the environment.
So specific means a certain area. Like, for example, we could say Thailand. That is a specific area. Or the rainforests of South America. That is a specific area. Population. All the members of a certain organism in a specific area. Here we are. Let's watch this video and then you will answer the question.
Forest fires can kill plants and animals, but they can also have long-term effects. They may damage an area so badly that surviving animals must move elsewhere.
So if there's a forest fire, and all of the trees here are gone and a lot of the grass is burnt away, what will these wildebeests need to do? Minang, what will the wildebeests do if the forest is burnt too badly?
I think the wildebeest will run to another forest.
Exactly. If there's no food here anymore for the herbivores, the wildebeest go to a new forest. What happens to the lions that eat the wildebeest? Daisy?
I think they will get hungry and don't have any food to eat.
So if they want to survive, what should they do, Daisy?
They have to run.
Yeah, they also have to move to a new place. What do you think might happen to the populations of plants and animals in a forest that has been destroyed by fire? Go ahead and raise your hand whenever you're ready to share. Vicky?
The animal will die or they will need to go to another place. The plant might don't have water and they will die.
Okay, very good. Yeah, if there's not water for a long time, maybe they can't grow back. Min Ai, go ahead.
The animals will go to another forest. The plants will die and have a new life.
Very good, okay. Those could both happen. Suck, go ahead, Suck.
Animal may move to another place. Plants may die and burn.
Excellent, very good. Ruby, go ahead, Ruby.
The animals will move to another forest. The plants may burn and they will die.
Very nice, all right. Mooney, go ahead, and then Kitty, you can go after Mooney.
The animal will move, although it will die. The plant may die and grow again.
Very good, you're right. The plants can grow again as long as the seeds are not completely burnt by the fire? Kitty, go ahead, Kitty.
The animals will need to move away, or if they stay there, they will die. And if they're lucky, they can find a new home there too. And the plants will can be burned and die, but they can grow back.
Excellent. Great job, Kitty. That was wonderful. All right. So, reacting to change. How do different animals react to change? Everyone go ahead and turn to this page, 326. First of all, this question, what do you think might happen to the populations of plants and animals in a forest that have been destroyed by fire? Looks pretty tied. I think a few more people picked this one. Nice. Good job. All right, now let's look at these. Nancy, can you please read about the wildfires?
During a wildfire, plants will die, but some plants reproduce. Some pine trees have cones that open and release seeds in fire. The seeds settle on the forest floor and grow into new plants.
Very good. So you can see in the first picture, plants are dying. But in the second picture, we have our pine cone that can release its seeds in the fire. Release means to let go. Like if you help a bird that is hurt, after it's better, you might release it into the wild. You might let it go. Simon, go ahead and read about this one.
The Amargosa will only live in certain parts of California. It depends on certain plants or for food. During a drought, plants die, so the boys move to new areas to find food.
Very good. So how does the vole survive changes in its environment?
It will find new places, hence for food.
Exactly. Its environment changes, it finds somewhere else. It doesn't stick around. Nice job, Simon. This pika. Oh, so cute. Nuna, we haven't heard from you in a while. Nuna, can you read about the pika?
This pika lives in the mountains of the northwest because it must to stay cool to survive. If an area becomes too warm, the pika must move further north where temperatures are colder.
Very nice. So for climate change, if there is climate change and the earth gets warmer, the pika will have to move further north. And the last one, Katie, go ahead.
A sudden change in temperature that is not seasonal could upset the natural system in an environment. This plant died because of a freeze that happened out of season.
Very good. So not in season, out of season means at the wrong time. So maybe the freeze did not happen in winter. The freeze happened in early spring. It got cold again in early spring, and the berries that just started growing froze and died. We call these late freezes or early freezes, and it can kill the plants that started growing. All right, so imagine your flowers are all blooming, it's springtime, and then bam, everything freezes again. Some of the plants cannot survive it. So in each picture, go ahead and circle what is reacting to the change, what plant or animal. All right, excellent job, everybody. Good reading. And reacting is answering something. If someone throws a punch at you, boom, boom, you react by going to the side, swatting it away. Reacting is how you respond to something. If someone yells at you, you might react by yelling. You might react by crying. All right, so these animals are reacting to the change. They might release seeds, they might move, they might die. All right, everyone, nice work today. Here's your homework. On each side of your fast and slow change drawing that you made on Monday, yesterday, circle one organism. Draw a new one if you need. Write 2 to 3 sentences on each organism and what they could do to survive the change. So, if this is a flood and I drew a tree, let's say the flood might move the tree's seeds. The big tree might die. It might have strong enough roots to survive. Okay? And that needs to be for each one. So altogether, you'll have 4 to 6 sentences. All right, bye everybody. I will see you tomorrow.
Bye.